Uh, so yesterday we talked about normal distributions. Normal distributions are not skewed to the right, they're not skewed to the left, they're actually bell curve, and we call them normal. They're symmetrical. Yesterday I introduced you to the 68, 99, actually, my bad, the 68, 95, 99.7 rule. Yesterday you and I drew a normal curve. Yesterday you and I talked about how that inflection point where the curve changes direction from down to right, that point is the first standard deviation above the mean. And remember, the mu symbol for mean is mu in Greek. And the same distance below a negative standard deviation is exactly at the same point, what we call the inflection point, where this curve changes direction. That's the first standard deviation. Same distance, second standard deviation, third standard deviation, and so on. That's where we left off. Now I'm going to explain why in the world this rule is called 68, 95, 99.7 rule. What the heck is that? Watch. What I want you to do now is go ahead and draw yourself another curve. Just like you see here. So you're gonna practice drawing curves. You're gonna get better and better the more practice you get. Sooner or later, yours will start getting closer to how awesome mine are. Why are you guys laughing? Okay, just kidding, just checking.
It's just to draw the exact same one again, but like.
Right, just draw another curve, and go ahead and put mu for mean, sigma for 1 standard deviation, 2 standard deviation. That's 2 sigma. 3 sigma, 1 sigma below, 2 sigma below, 3 sigma below. Go ahead and do that, and I'll give you about a minute. Why am I making a big deal about normal curves? Here's why. If you're studying the LA Dodger statistics, if you're studying Real Madrid, if you're studying fastest cars, if you're any data that you're studying, if that data makes a normal curve, a normal distribution, like I said yesterday, fireworks go off. Huge, huge fireworks go off. And here's the fireworks. Put your seatbelt on. So yours says mu here, not 0. So go ahead and put an arrow from the first standard deviation below and one above. Put arrows and go ahead and put 68% of data. Just like you see here. And then go ahead and put arrows from the second below and the second above and go ahead and write 95% of the data. It's always in between those two values. And then an arrow to the third below. Remember, these are all sigmas, by the way. My bad. And go ahead and write 99.7% of the data. And then go ahead and write down these 3 bullets here. This is the meat of the rule. This is huge in statistics. And by Moreno's laughter, it's starting to indicate he doesn't understand how huge this is. When they say observations, that's just a fancy schmancy way of saying data values. Okay? So this means 68% of the data values fall within 1 standard deviation of the mean. Because data values are stuff you observe. Whatever you're studying, whether it's the LA Dodgers or my class or human beings, every data value is an observation. So this is a fancy word for data values, okay? Just keep that in mind. You're in the role of a scientist, right, Moreno? Yeah. What we're going to do now is we're going to figure out how useful this rule is about normal distributions. Go ahead and write example 1 down on your notes. Go ahead and write it down. Munguia's class scored on the quiz an an average of 72%. Yes. So the average score of my last quiz was 72%. The standard deviation was 10. How much of the class scored between 72% and 82%? Assume the distribution was normal. I'm going to write that down. I'll give you about a minute. I'm going to show you how to use this rule now. It's going to get crazy in here. Okay, so seniors in here that need to graduate, I recommend you focus like a laser beam, because the last thing you want is to have trouble on the current work and still be catching up on past work. That's the place you don't want to be in my class with, like, what, 8 days left to go. So my wholehearted, I admonish you to really focus. Stay with me, buddy. All right, watch this. So this is my class. They took a quiz-a-rooney. The class had an average score. If I took all the scores of my class, I averaged them out. It was a 72%. That was the mean. And it says assume the distribution. In other words, if I created a histogram of my class, it would be normal, which means it would be symmetric. So go ahead and draw another curve with me. Go and do that with me. Again, the more you do it, the better you're going to get. I'm telling you. For an extra stamp, what would this be here? Nice, the mean. And what is the mean in my class here? It's mu, huh? But what in this class, this example, what is the mean? So go ahead and put 72 here. You got it. So far, so good. So the mean is 72. I put it there. Okay, right here is the first standard deviation above. I'm going to put that. Remember, it's where the curve changes direction is the first standard deviation above and below. Going to draw that. In other words, it's the first sigma above, first sigma below. What is the sigma's value in this example? In my class, what is sigma? 10. Look at it, standard deviation. That's what sigma means. Sigma is 10. So what would the first standard deviation be then? Above 72 if it's 10. Help. 82. Thank you. Go to put 82 with me. You're awesome.
Just for your review.
Thank you. The order?
70 cents under.
Of the max, huh?
Well,
I'll check it out.
yeah, so just review it and then we can talk.
Thank you, Ms. Wood. All right, okay, so that's a standard deviation above. What would be a standard deviation? 62. Awesome. We're rocking and rolling. This is how it works now. So let's do another standard deviation below. What would this value be? A score of 52 on my quiz. And then 2 standard deviations above would be a score of 92. It's Moreno, the data. All right, here we go. The question, what's the mission here? How much of the class scored between 72 and 82? Okay, so here's the scores of 72 and 82, and it's asking how much of the class scored in between there. So look what I'm going to do. I'm going to shade in this region here. In other words, the question's asking, what percent of the class is that? That scored in between 72 and 82.
10%.
She says 68%. Give me an argument, Ms. Contreras. Extra stamp. What percent would that be, that part that I shaded? What percent of the class of my class that took the quiz, what percent is that I just shaded?
Because it falls in between
Okay, so it falls in between the mean and what?
first.
The first standard deviation, okay. You said 64, huh? Or 68? 68? Acevedo says 34, what? 34%? How'd you get 34%?
Because here, on the mean, the first two
Uh-huh.
on where it says 62 and 82,
Yes.
it'll be 68%.
Of the data, huh?
Yeah.
So, Acevedo got it. Like this, look at the 68, the 68, 95, 99.7 rule says this. A standard deviation below and a standard deviation above the data all the time, that's 68% of the data. And I'm asking for half of it now. So Mr. Acevedo took 68, chopped that puppy in two. 68 divided by 2, it's 34. So this represents, the shaded part is 34% of the data. What to put 34% of class. It makes sense, doesn't it? And what you said, okay. Okay. You want me to explain it again, or you want to just wait?
Yeah, I don't get how you got there. Well, I know you divided by 2, right?
Right, 68 divided by 2 is 34.
So it's always 62 divided by 4.
Well, remember, my question is, this region right here between 72 and 82, what percent of the class is that? Well, it's half of this percent. Watch. Let me shade in the rest here. Watch this, Martin. See, all this that's shaded, that's 68% of the data according to the 68, 95, 99.7 rule. The rule we just wrote down. It says if it's a normal curve, then all the data that's in between the first standard deviation above and first standard deviation below the mean, that's always going to be 68% of the data. Always, if it's a normal curve. And now I'm asking, okay, then what's this then? What percent would this be? What percent of my class score there? Well, he took 68 and divided by 2. 34.
So if it was further, if it was like, what's the score between 62 and 82? You would be on 3 of them or something like that?
Well, it would be 68% of the data, huh?
Yeah.
That makes sense?
Yeah, just have to keep doing more.
Yeah. More practice, we'll get it. Don't worry. Last example, ready? The second example is going to be still the same data. Go to write this down. What percent of the data scored between 52 and 72? Extra stamp for Acevedo so far and Moreno. So, I got an extra stamp because they had the last one. Alright, so here's example 2. Go to write this down. Last example of the day. What percent of the class scored between 52% and 72%? So let me draw my curve again, or you could use the same curve if you already still have that old one. So the mean was 72. One standard deviation below is 62. 2 standard deviations is 52. One standard deviation above was 82. 2 standard deviations is 92. The question is now, what percent of the data, and I'll color it purple here, what percent of the data scored between 52 and 72? In other words, right here, watch. What percent of the data is this?
Finally did it, so it's better.
Telling you. You said 7%? Can you please give me an argument, Moreno? Well, we need arguments in math. We need arguments in math. We need arguments in life, actually. I'll tell you what, you're on the right track, but Contreras has got the argument. She can save the day.
Wait,
Never mind, sorry. I jumped the gun there. I got too excited. Gonzalo, say it. Save the day. I'm sorry. Who's going to save the day?
Wait, what do you?
62.
I'm so confused.
I just shaded the region that the question's asking for. What percent of the data is in purple?
47.5.
Acevedo, save the day again. What's up with you, Acevedo?
I was on the high.
Let's see Acevedo's reasoning.
Hey, right on.
So, Acevedo reasoned, he reasoned this way. Look at 2 standard deviations below and 2 standard deviations above the mean is 90, how much percent? 95% of the data. You just wrote that down a little while ago. And what we're dealing with is half of 95%. So Acevedo just took 95%, chopped that puppy in half. What was the figure?
Wait,
47.5. So the answer then is 47.5 of the data, or put of the class. Well, that doesn't give you a hug, don't worry. 47.5% of the data of the class scored between, ready? Between 52 and 72.
okay, this makes sense.
Oh, it's gonna be okay, buddy. Right. So, Acevedo took 95, chopped that in half, divided by 2, and you got 47.5. It's half of 95. So this is key now. You got to really familiarize yourself and become acquainted with this, what you just wrote down. 68, 95, 99.7% of the data, if it's normal. Grab your computer, give me a grade check.